My name is Vishnu Kumar. I am a content and cloud architect. Today we are going to look into setting up of Documentum content management system on a Google Kubernetes engine. So what are the prerequisites for this setup? So you would need a Google Cloud subscription, access to Documentum content server and Documentum administrator images, Docker images. So let me briefly show you. So I've registered for a Google Cloud subscription. So let me briefly show you how to create a Kubernetes cluster on a Google Cloud. So you need to log into your Google subscription. Click on the Kubernetes. So clicking on the create clusters. So I'm setting up a region close to me. So I'm choosing the 1.5. I'll stick to 2 nodes instead of 3. For the zonal. And I'll stick to the 2 nodes. So this is just I'm setting up a development environment. So I've chosen a regional and a 2 nodes. So you would have a behind the scenes, it creates two VMware instances for running your images on for running your Documentum images. Now the cluster is ready. It normally takes 3 to 5 minutes for the cluster to be created. So once the cluster is ready, let's try setting up our desktop to talk with the Kubernetes cluster. Okay. To do that, you would first need to set up the Google Cloud SDK on your desktop and also the kubectl binaries on your machine. So Google has given a good installation document to set up of both SDK and the kubectl. So I will share this link later. So I've already set up the. So once you got the Google Cloud SDK set up and the kubectl set up, you need to configure the cluster configuration on machine. So the easiest way would be using the G Cloud SDKs. So click on the connect button and it gives you the command which you need to use to configure your cluster on your desktop. So copy this command, navigate to a command prompt. So now it is set up. Once the SDK has been set up, okay, I've also got the kubectl installed. So with this, we are ready to start creating our start working with our Kubernetes cluster. Okay. So the prerequisite for any Documentum container solution is you would need to have the content server images and the Documentum administrator images. So already downloaded the images and also I have pushed into my Google Container Registry repository. So I did it using following the below steps given in this link. Okay. So let me quickly show that as well. So I've got both the repositories, content server and the DA client. So I have pushed the 20.2 version for both content server and the Documentum administrator web client. So now we have got the cluster, the images, and also the desktop is configured with the SDK and the cluster configuration. So let's get started creating some pods. Pod instance are the running containers within the Kubernetes. So Kubernetes helps us to create the resources using the YAML scripts. So for setting up of a very basic Documentum environment, we would need around 4 pods. Okay? One for the database, one for the doc broker, other 2 for Docbase and the DA administrator client. So these are the minimum 4 pods you would need to set up any Documentum environment. So let's briefly look into those four pods configurations. So config map is the where you put all your configurations. So I put the configurations. One of the key configuration for the Postgres is the Postgres password. So I'm putting that in a config map. Next is your persistent volume claim, which is your what is the storage you want to use. Okay, so I've configured persistent volume storage for the Postgres database. And next is the stateful set, okay, which is the actual running instance of your database. So I'm using the default Postgres image of version 11.7, and I have set up all the pre-request data for it. So this is the next is the service. Service is nothing is the one which exposes your Postgres service to the cluster. Okay, so let's quickly create the Postgres cluster. Sorry, the Postgres pod. So the pod is getting created. Okay, still pending. So go to the Kubernetes engine, workloads, you see the Postgres server. Click on the container logs. Once the Postgres is ready, you could see the logs are updated here and it's ready to take connections. Now let's quickly look into the doc broker ML script. So Documentum has recommended to create doc broker as in one pod and Docbase in a separate pod. Okay, this is mostly for so that you can scale doc broker Docbase individually. So similar to Postgres, doc broker has got its own config map where all the configurations required for the for the installation of doc broker. So root password. So we are trying the doc broker and the Docbase use the same image. So that's why I use the property only doc broker to tell the installer to create only the doc broker, and they use the install owner password and Kubernetes too, which tells the doc broker installation that it's a Kubernetes installation, because Documentum installation handles different way if it's a Kubernetes. Okay, then then you create a stateful set which is your actual template for your pod. So we use the same image for the content server. Okay, so readiness probe is the one which tells the doc broker is ready and allows you to take new accept connections, and liveness probe is the where it ensures that the doc broker is up and running. If that liveness is not successful, it tries restarting the pod. Okay. Then the doc broker ports and the volumes are configured, then the service. So these are the configurations for the doc broker. Let's try creating the doc broker. So doc broker creation usually takes around 3 to 5 minutes. So let's wait for that. Now the doc broker pod is up and running. Let's quickly check the logs as well. Yes, the doc broker installation is successful. Let's try setting up the Dockbase. So let's quickly look into the Dockbase YAML script. So similar to others, it has got its own config, and Dockbase has got additional configurations like database host, which is your Postgres service resource name, database password, port on which your Postgres is running, the user, default user for Postgres is Postgres, then a Dockbase ID, name, installation owner name, okay, and your doc broker service name, and the port on which your doc broker is running, and this is your cluster name. This is your default cluster name, global leadership password, then the persistent volume which you want to use, then the stateful set, which is actually your pod template configuration. So it is using the content server default Docker image. So it has got various port like the Dockbase port, doc broker port, container JMS port. Also it has got the thumbnail server and the thumbnail server ports. Okay. So Dockbase pod requires various volume bounds for successfully deploying the pod. So these are all the volume bounds it required. Then the service configuration, which helps us to interact with the Dockbase on your file, on your cluster. So once this is done, so usually the Dockbase setup takes more time, around between 10 to 15 minutes. Let's wait for it. Now the Dockbase pod is also ready. So let's look into the logs and confirm it. The log doesn't have any errors, and looks quite clean, and all the processes have been started. We can also log into the particular server to validate, but in a real-time instance where you got around 10 or 20 pods, it may not be possible. Since this is a single pod, we can quickly log into the pod and see the logs ourselves. So first we need to get the name of the pod. This is our repo pod, and to connect to the particular machine, particular pod, this is the below command, -IT, which tells us that it's an interactive mode. Okay, now we are connected. Yeah. Let's quickly check the Dockbase logs. So no errors, and the logs look quite good. So the Dockbase is up and running. So now we have got the database, doc broker, and the Dockbase up and running. Let's deploy the Documentum administrator web client. So already put up a YAML script for it. So this is the service. So this is service for exposing the port. So, and this is the volume. What are the volumes we want to use? And the actual file, template of the pod. Okay, let's quickly run this. still within the pod. Now the client is created, so usually takes around a couple of minutes. Okay, so if you see just a quick look into those files, okay, if you see the actual pod template for a DA is deployment, and for the doc base and doc broker is, and the Postgres is stateful set. Okay, so mostly the default type of pods are stateless, where you wouldn't have any persistent data within your pods. Okay, but stateful set are quite different from your pods, by which you retain. So this brings you the statefulness to your pod. So this ensures that all your pods comes up in a sequential order. So for example, if you want to bring up like multiple content servers, content server for a single repository, you would have a replica as 2 here. Okay, but since it is a stateful set, okay, it starts all the containers in a sequential order. So first it comes up with the primary content server with the repo, and then the secondary content server, because it's a single image, but both the images work in a different ways. Okay, both serves a different purpose. Okay, that's why the stateful set is used, where you would have some statefulness. Okay, statefulness within the what to tell that this is your primary content server, another one is secondary content server. So that is why we kind of create all our doc broker, doc base, and Postgres as your stateful set. But your DA client, okay, which doesn't have any, which are just a web clients, okay, and doesn't have any doesn't needs to hold any stateful state on the pod. Okay, that's why you create it as a deployment. Okay, so deployment are kind of the template for creating a stateless pods. Okay. So let's quickly check whether this pod has been created. The pod is running now. So this is the IP on which the pod is running. So this is IP, and this is the port on the particular node on your clustered VM machine. Okay, so I've taken this port from the cluster, and I have just exposed it. Let's try logging in. So now we are logged into our repository. So it says the repository is system repo, and the host name is the repository pod, and connection broker is the system doc broker. So this is how you would run a basic development environment of Documentum on Kubernetes, on a Google Kubernetes. Hope this video helps you. Thank you all.